Hello geometry students. Here's your lesson for section 1-4, pairs of angles. Missy McCarthy, Okemos High School math instructor. In this lesson, by the end of the lesson, you should be able to say, I can identify pairs of adjacent angles and decide whether or not they form a linear pair. Define and find the measures of complementary and supplementary angles. And identify pairs of vertical angles. So in order to meet that first objective, to identify pairs of adjacent angles and decide whether or not they form a linear pair, we have the definitions of adjacent angles and linear pair. So for our first definition, let's see what is important to identify when angles are adjacent. Adjacent angles are two angles in the same plane with a common vertex. In this case, the common vertex would be right here. Not sure what that is, that mark is. Anyway, with a common vertex and a common side. In this case, the common side would be right here. But no common interior point. So that means the interior of angle 1 is completely separate from the interior of angle 2. So in this diagram, angle 1 and angle 2 are adjacent angles. Common vertex, shared side, no common interiors. A linear pair of angles is a pair of adjacent angles whose non-common sides are opposite rays. So, again, one of the defining characteristics of a linear pair is that they are first adjacent. So we look here at these angles and we ask ourselves, are they adjacent? They have a common vertex. They have a common side. They have no common interiors, so yes, they are adjacent. And then we ask ourselves, do the other sides that are not common form opposite rays? So we got this here, we got this here, and they form opposite rays, so angles 3 and 4 are what we call a linear pair. So we're going to tell whether or not the angles that they give us here are only adjacent, or whether they're adjacent and form a linear pair. So let's look at angles AEB. I'm going to trace that out. Angle AEB, that's there, and angle BED. Angle BED, that one's there. So they are adjacent because they meet at E and they have a common side, ray EB, and then the interior of this one is not matching up or not intersecting with the interior of the other one. And then these form a line. So I would say this is adjacent, that's my short for adjacent, and linear pair, or form a linear pair. All right, let me erase here and start fresh for B. Angles AEB, AEB, that's that one, and angle BEC, BEC is that one. Common vertex, common side, no shared interior points. These do not form a linear pair, so these are only adjacent. All right, erasing one more time so that I can do the last one. DEC and AEB. Common vertex, but no common side. So these are not adjacent. All right, so we're going to tell whether these angles are adjacent and form a linear pair, or not adjacent. So why don't you pause the video right at this moment and see if you can't tell, and then press play and see what I came up with. So I'm looking at angles 5 and 6, common vertex, no shared interior points, and the remaining sides are opposite rays. So I would say adjacent and linear pair. Okay, so now I am looking at angle 7 and angle SPU. Angle SPU is this one right here, and angle 7 is right here. They share an interior, so it is not adjacent. And then lastly, we are looking at angle 7 and angle 8. Angle 7 is here. Angle 8 is here. Common vertex, no common side, so they are not adjacent. All right, our next angle pairs are complementary angles and supplementary angles. Complementary angles are angles that whose measures sum to 90 degrees. A and B in this particular picture are complementary because the measure of angle A plus the measure of angle B equals 90 degrees. And then supplementary are two angles whose measures sum to 180 degrees. In this case, A and C are supplementary. So we could say the measure of angle A plus the measure of angle C equals 180 degrees. So complementary, sum to 90, supplementary, sum to 180. Okay, in this example, we are going to find the measure of a complement of angle F and a supplement of angle G. So let's focus on the complement of angle F. So the first thing I'm going to say is that the measure of angle F is equal to 59 degrees. So to find the complement of angle F, if I know that they sum to 90 degrees, I'm just going to do 90 minus angle F. So 90 degrees minus angle F is going to give me its complement. And if I do 90 minus angle F, the complement of angle F is 31 degrees. I'm going to use that same strategy to find the supplement of angle G. The measure of angle G is not a number this time, it's actually an expression. 7x plus 10 degrees. So if I want to find the supplement of angle G, I am going to end up doing, instead of 90 minus, I'm going to end up doing 180 minus angle G. Now, because angle G is an expression, I need to make sure that I do some computation here just to make sure that I get the correct expression. So down here, I'm just going to compute it. I'm going to do 180 minus angle G, which is 7x plus 10. I'm going to distribute my negative, and I'm going to get 180 minus 7x minus 10. And then I'm going to come up here. The supplement is actually going to be 170 minus 7x degrees. So if I start with a number and I ask for the complement, I end with a number. If I start with an expression and I ask for the supplement, I end with an expression. But the way that it's found remains the same. In order to find the complement, you should do 90 minus the angle that you're given. And in order to find the supplement, you do 180 minus the angle that you're given. All right, here's a different type of problem that deals with complementary and supplementary angles. And I want you to be careful with these two types of problems because the previous example that I did and this one, students tend to mess up a little bit. So make sure that you're looking at the defining characteristics of each of these types of problems. In this one, it says an angle is 10 degrees more than 3 times the measure of its complement. It's 10 degrees more than 3 times the measure of its complement. So we really have two angles that we're dealing with here. The first angle we don't know. I'm going to call that angle X. That's our first angle. We do know something a little bit about the second angle. We know that it's 10 degrees more than 3 times the measure of the first angle, or its complement. So the second angle could be represented by 3x plus 10. Now the other piece of information that we do know is that these angles are complementary, which means that they sum to 90 degrees. So we can write an equation and find the measure of both angles or just the complement. So my equation would be x, the first angle, plus 3x plus 10, the second angle, has to add to 90 degrees. So we end up with 4x plus 10 is equal to 90. Subtract 10 from both sides, and we get 4x is equal to 80. Divide both sides by 4, and we get x is equal to 20. So that means our first angle that we were talking about before, this angle is 20 degrees, which means that its complement, if we plug 20 in there, we would get the complement is 70 degrees because x is 20. Plug 20 right back in there, do your computation, and the answer is its complement is 70 degrees. So let's write a definition for vertical angles. Vertical angles are angles who share a common vertex and whose sides form opposite rays. So if we look at the diagram that we're given, we can see that angles 2 and 4 have a common vertex, and this side of angle 4 and this side of angle 2 form opposite rays. This side of angle 2 and this side of angle 4 form opposite rays. So in this particular instance, we can say that angle 2 and angle 4 are vertical angles. We can also say, looking at this diagram, that angle 1 and angle 3 are vertical angles. They meet at the same vertex. These sides form a straight line, and this pair of sides form a straight line. So let's name some pairs of vertical angles, and this will be our last example before we review our I can statements. So here's one pair of vertical angles. This guy right here, angle HML, and this one here, and angle JMK. That's one pair of vertical angles. Another pair of vertical angles would be angle HMJ and angle KML. Those are also vertical angles. So I'm going to highlight the vertical angles just for emphasis. This angle right here and this one right here. And then the other angles that are vertical angles would be this one here and this one here. So just to revisit your I can statements, can you identify pairs of adjacent angles and decide whether or not they form a linear pair? Can you define and find the measures of complementary and supplementary angles? And can you identify pairs of vertical angles? See you in class.